Papaya appears soft, delicate, and entirely natural, a fruit associated with freshness, ripeness, and short shelf life. Yet every day, millions of papayas travel thousands of kilometers, sit on store shelves for months, and arrive in homes unchanged in texture, flavor, and safety. This transformation does not happen by chance. It is not achieved by preservation alone, and it does not rely on nature to slow itself down. Behind this familiar fruit lies a tightly controlled industrial process, where time, temperature, and precision determine whether papaya survives or fails. This is the journey of papaya, from farm to factory, and from fragility to stability. Papaya is one of the most challenging fruits to process at an industrial scale. Its flesh is soft, highly sensitive to pressure, and rich in natural enzymes that continue breaking down the fruit even after harvest. Unlike firmer fruits, papaya ripens unevenly, meaning two fruits from the same tree can behave very differently during processing. Its high moisture content also creates an ideal environment for microbial growth if temperature and handling are not tightly controlled. For large-scale production, these characteristics present a serious risk. Without precise timing, gentle handling, and immediate intervention, papaya deteriorates rapidly, long before it ever reaches a factory line. This is why the industrial journey of papaya must begin long before the machines start running. Once papayas reach optimal maturity, time becomes the primary threat. Unlike durable produce, papaya cannot tolerate rough handling or delays without rapid quality loss. For this reason, harvesting is done carefully by hand, minimizing pressure and surface damage that could accelerate enzymatic breakdown. Immediately after harvest, the fruit enters a controlled cold chain. Refrigerated transport is not used to freeze or preserve the papaya, but to slow biological activity and microbial growth. Every hour saved during this stage directly affects the stability of the final product. In industrial processing, speed is not about efficiency alone. It is about preventing nature from moving faster than the factory can respond. When papayas arrive at the factory, the focus immediately shifts from speed to safety. Before any cutting or processing can begin, each fruit must be treated as a potential contamination risk. Dust, field residues, and microorganisms acquired during harvest and transport must be removed completely. To achieve this, papayas enter a multi-stage washing system using controlled water flow rather than mechanical scrubbing. This method cleans the surface without damaging the delicate flesh. Advanced water management ensures consistent hygiene while preventing cross-contamination between fruits. At this stage, cleanliness is not optional. A single compromised fruit can jeopardize an entire production batch, making washing one of the most critical control points in the factory. After washing, papayas move into a stage where human judgment is no longer sufficient. At industrial scale, quality must be measured, not assumed. Advanced optical sorting systems scan every fruit in milliseconds, analyzing color, surface integrity, shape, and internal defects invisible to the naked eye. High-speed sensors and cameras compare each papaya against strict predefined parameters. Fruits that fall outside these limits are automatically removed from the production line. There is no interpretation and no hesitation, only data-driven decisions. In modern food processing, consistency is the ultimate standard. By allowing machines to decide what qualifies, the factory eliminates variability and ensures that only papayas capable of surviving the next stages continue forward. Once approved by optical sorting, papayas enter the preparation stage, where natural irregularity must be eliminated. Every fruit differs in size, thickness, and internal structure, yet the machines that follow require absolute uniformity. To resolve this mismatch, automated systems peel, split, and deseed each papaya with precise, repeatable movements. Laser-guided cutters and calibrated blades ensure consistent dimensions, reducing waste while maximizing usable flesh. Seeds are removed completely to prevent interference in downstream processing. What emerges is no longer raw fruit, but standardized material ready for industrial transformation. At this point, papaya is no longer treated as produce. It becomes a controlled input, shaped to meet the demands of machines rather than nature. At this stage, the journey of papaya is into two distinct industrial paths. Although the raw material is identical, the intended final products demand entirely different treatments. One path leads toward canning, where stability and long-term preservation are the priority. The other moves toward purees and smoothies, where texture, color, and consistency become critical. This separation is not arbitrary. Each process requires unique timing, equipment, and control parameters. Once the papaya crosses this point, it can no longer switch destinations without compromising quality. From a single fruit, two outcomes emerge, each shaped by a precise sequence of decisions made long before the final product reaches the consumer. For papaya destined for canning, the objective is long-term stability without sacrificing structure or flavor. After precise filling with fruit and syrup, cans are hermetically sealed to prevent any external contamination. They then enter pressurized retort systems, where high-temperature steam and controlled pressure work together to eliminate microorganisms. This process is not simple cooking. Temperature, pressure, and time must be balanced carefully to ensure safety without breaking down the fruit's texture. Too little treatment risks spoilage. Too much destroys quality. Inside the retort, papaya is suspended between fragility and endurance. When the cycle ends, the fruit emerges transformed, shelf-stable, safe, and prepared to outlast seasons rather than days. Papayas assigned to puree and smoothie production follow a different transformation. Here, stability depends not on sealing, but on controlling texture at a microscopic level. The fruit enters industrial pulpers, where centrifugal force breaks down fibers and releases a smooth, uniform pulp. This pulp is then transferred into large blending tanks, where precise ratios of other fruit components may be introduced. High-powered mixers ensure even distribution, eliminating inconsistencies that could affect taste or appearance. To prevent separation during storage, the mixture undergoes homogenization, forcing particles into a stable suspension. In this process, flavor remains natural, but texture is engineered. What consumers experience as smoothness is the result of carefully controlled mechanical force, applied at exactly the right moment. Once the papaya mixture reaches its final consistency, it moves immediately to the bottling stage. Here, speed becomes essential, but never at the expense of hygiene. High-speed rotary filling lines dispense precise volumes into each bottle while maintaining a strictly controlled environment. Every second matters. Extended exposure increases the risk of contamination, while uneven filling compromises product stability. Automated sensors continuously monitor fill levels, seal integrity, and flow rates, making real-time adjustments without stopping the line. Immediately after filling, bottles are sealed to isolate the product from external air. This rapid transition from blending to closure ensures that freshness is preserved at scale. At this stage, industrial efficiency is measured not only by speed, but by how effectively it protects the product from the outside world. After sealing, finished products enter the packaging phase, where individual units become part of a larger system. High-speed spider robots and automated packers arrange bottles and cans into cases with consistent precision. Each movement is calculated to minimize impact, prevent misalignment, and maintain throughput without interruption. Once packed, cases move toward robotic palletizing stations. Here, powerful robotic arms stack entire layers in perfectly aligned patterns, creating stable pallets designed for transport and storage. What would take hours of manual labor is completed in minutes, with flawless repeatability. At this point, the scale of production becomes unmistakable. Thousands of individual products are no longer seen as single items, but as organized units within a global distribution network, ready to move beyond the factory walls. Once palletized, products move into controlled storage environments, where organization becomes just as critical as production. Automated guided vehicles transport pallets through precisely mapped warehouse routes, reducing handling errors and maintaining consistent flow. Each pallet is tracked digitally, allowing real-time visibility of location, batch history, and destination. Temperature, humidity, and storage duration are carefully managed to protect product integrity before shipment. This stage often remains unseen by consumers, yet it determines whether products arrive safely and on schedule. Only after passing through this final layer of coordination does the factory release its output to the distribution network. Here, the journey shifts from manufacturing to logistics, where efficiency, accuracy, and timing ensure that the results of every previous step reach the world exactly as intended. What begins as a fragile tropical fruit ends as a stable product designed for global distribution. Along the way, papaya passes through systems that control time, temperature, pressure, and motion with extraordinary precision. Nothing in this journey is accidental. Every step exists to manage risk, preserve quality, and transform variability into reliability. What you have seen is not simply food processing. It is the coordination of agriculture, engineering, automation, and logistics into a single continuous flow. From harvest to storage, each stage depends on the one before it. Inside this factory, fragility is not ignored. It is engineered, managed, and ultimately overcome.